Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, Scrapling, a Python-based adaptive web scraping framework that handles everything from a single HTTP request to a full-scale crawl. It gained nearly 2,000 stars today alone, signaling that developers everywhere are hungry for a scraping tool that actually adapts to modern dynamic websites without constant babysitting. Web scraping is one of the oldest problems in software engineering, and yet the core frustration has never really been solved. You spend a weekend building a perfectly functional scraper, the target website updates its layout, and suddenly, you're back to square one. A Python project called Scrapling is attacking this exact problem head-on, and developers are paying attention fast. It accumulated nearly 2,000 GitHub stars in a single day, hitting over 12,000 total. That kind of momentum usually signals something genuinely different is happening. Scrapling is an adaptive web scraping framework built in Python by developer D4Vinci, known online as Karim Shoair. It positions itself as a unified solution for everything, from a single HTTP request all the way to large-scale concurrent crawls. The design philosophy is called one library, zero compromises. The numbers back the enthusiasm: 12,535 total stars, 1,970 added in a single day, 846 forks suggesting real adoption beyond curiosity. The project has also attracted commercial sponsorship from established names in the proxy and scraping infrastructure space. That signals the community views this as production-grade tooling, not just an experimental side project. With 92% test coverage and TypeScript support layered on top, it reads less like a weekend hack and more like a serious attempt to rethink the web scraping stack from first principles. To understand why Scrapling matters, you have to feel the real pain of maintaining web scrapers at scale. Traditional tools like BeautifulSoup, or even the more powerful Scrapy framework, rely on explicit CSS selectors or XPath expressions. These are rigid paths that describe exactly where a piece of data lives in a page's HTML structure. They work beautifully until the website you're targeting refreshes its front end. A redesign, a component library swap, a minor class name change, any of these can silently break an entire scraper pipeline overnight. For teams running dozens of scrapers against frequently updated sources, this becomes an endless maintenance treadmill. The second persistent headache is anti-bot defense. Modern websites deploy sophisticated systems like Cloudflare Turnstile, an automated security challenge that distinguishes real browsers from scripted requests by analyzing behavior patterns, browser fingerprints, and TLS handshake signatures. Bypassing these reliably has historically required assembling a patchwork of specialized libraries, browser automation tools, and proxy infrastructure. Scrapling's argument is that all of this should come from one coherent, well-engineered package. The architecture is cleanly layered into three distinct levels. At the bottom sits the fetching layer. It offers three different strategies through a unified interface. The standard fetcher handles fast HTTP requests and can impersonate browser TLS fingerprints, which defeats server-side detection at the network level. Dynamic Fetcher brings full playwright-based browser automation for JavaScript-heavy pages. And Stealthy Fetcher goes even further. It injects JavaScript to mask telltale automation signals like the WebDriver property that browsers expose when controlled programmatically. That's what enables Cloudflare Turnstile bypass right out of the box. In the middle sits the parsing layer, centered on a selector object. Performance benchmarks here are comparable to raw LXML, roughly 2 milliseconds for text extraction across 5,000 nested elements. That makes it 800 times faster than BeautifulSoup in that specific test. But the genuinely novel piece is the adaptive parsing algorithm. When you first scrape an element with the auto, save flag enabled, Scrapling stores a structural signature of that element, not just its CSS path, a composite fingerprint incorporating its tag type, attributes, text content fragments, and its relationship to surrounding DOM nodes. If the website restructures itself, passing the adaptive flag on future fetches triggers a fuzzy similarity search against the new DOM, finding the best matching element automatically. Element similarity detection runs at 2.39 milliseconds versus AutoScraper's 12.45 milliseconds, a five-fold performance advantage. At the top sits the crawling orchestration layer. Think of it as a Scrapy-like spider framework that handles concurrent requests with configurable throttling, multi-session routing, so a single spider can use different fetchers for different URL patterns, and checkpoint-based pause and resume, so a long crawl interrupted by a network outage can restart exactly where it left off. A streaming mode lets you process items as they arrive, which matters for pipelines feeding live dashboards or real-time data products. There's also MCP server integration. MCP stands for Model Context Protocol, a standard for connecting AI assistants to external tools. It allows language models, like Claude, to delegate targeted web extraction to Scrapling before processing the retrieved content, reducing token consumption by working on pre-filtered data rather than raw HTML. The practical use cases span several distinct professional categories. Data scientists pulling structured data from e-commerce sites or news aggregators can deploy scrapers with significantly reduced maintenance overhead. The adaptive parsing effectively absorbs minor structural changes that previously required manual intervention. Infrastructure engineers building large-scale monitoring systems get concurrent crawling, proxy rotation, and fault tolerance without assembling those capabilities from separate libraries. AI developers building retrieval pipelines face a specific cost problem. Feeding raw HTML into a language model wastes tokens on markup that carries no semantic value. The MCP server architecture addresses this directly by extracting only the targeted content before it reaches the model. Getting started is a single pip command for the parser alone, with optional extras for fetchers and browser dependencies. A Docker image with all browsers pre-installed is automatically built with each release, which removes one of the most common friction points for deploying browser-based scraping in containerized environments. The interactive shell and command line extraction tools also mean non-developers can run one-off extractions without writing any code at all. Developer response on Hacker News and scraping-focused publications has been strongly positive, with particular focus on the performance benchmarks and the adaptive parsing concept. The Web Scraping Club on Substack highlighted the framework's integration story as the key differentiator, the idea that you no longer need to compose Scrapy with Scrapy Playwright and a proxy middleware library to get equivalent functionality. The measured concerns are realistic rather than fundamental. Browser-based fetching introduces overhead inherent to running actual browser processes, trading speed for capability. The adaptive algorithm operates as a black box from the developer's perspective. When it fails to locate the right element, diagnosing the mismatch is harder than debugging a broken XPath expression. And the anti-bot bypassing capabilities are in a perpetual arms race. What works against Cloudflare today may require updates as defenses evolve. No widespread stability complaints have surfaced, though, which is notable for a project at this growth velocity. The deeper question is whether Scrapling signals a maturation point for the web scraping ecosystem, or whether it's entering an increasingly difficult operating environment. Regulatory scrutiny around automated data collection is intensifying in multiple jurisdictions, and the technical sophistication required to bypass modern anti-bot systems pushes closer to legally and ethically contested territory. The project includes a standard disclaimer about educational use, but the capability set is explicitly production-grade. For the developer ecosystem, the consolidation argument is compelling. Python's scraping landscape has been fragmented for years. Scrapy for scale, BeautifulSoup for simplicity, Playwright for JavaScript, random libraries for fingerprint spoofing. A well-maintained unified framework could substantially lower the barrier for building reliable data pipelines. The risk is that the ongoing maintenance burden of keeping anti-detection capabilities current may prove unsustainable for an open-source project without significant commercial backing. Scrapling's core contribution is architectural clarity applied to a genuinely messy problem. It's not the first tool to do any single thing it offers, but it may be the first to assemble all of them coherently into a single, well-tested, well-documented framework. For any developer who has felt the specific frustration of maintaining scrapers against websites that keep moving the goalposts, the adaptive parsing feature alone makes this worth a serious look.
That's all for today's Dev Covery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.